you turn to page 140, first thing you have at the bottom of 140 that I would like you to highlight is this sentence. A radical equation is an equation, makes kind of sense that it had equation in it, and it's an equation, with at least one radical where there is a variable inside. So we have a square root and there's an x inside the square root. So what is going to happen with questions like this? Here I have the square root of 5x equals 10. We have to come up with algebra to get x by itself. The problem is, currently the x is inside of a square root. And we want just an x all by itself, not inside of a square root. So we have to get rid of that square root. Any ideas on how to get rid of a square root? Square. Makes sense that you get rid of a square root by squaring. So we square both sides, and that gets rid of the square root, and now we've got a question that is just like grade 9 math. How would I get x by itself? I'd have to divide both sides by 5, and I get 20. But what's different about a square root equation is we are always going to have to verify. And the reason we have to verify is sometimes there are numbers that don't start the same, but if you square them, they end up the same. For example, everyone would agree that 9 is equal to 9. If you got 9 equals 9, you'd feel pretty good about yourself. You'd be like, yes, I think things worked out quite well. However, there's something that I could have started with that if I squared gives me 9 equals 9, but at the beginning, they weren't the same. I could have started with 3 on this side and a negative 3 on this side. Those are not equal. However, if I squared both sides, I get something that is equal. Sometimes, when you square both sides, you think you found an answer, but it was just playing tricks on you. It's actually not an answer. So we're going to see that happen in some examples today. So something new in a radical equation is that you have to check. It's not a bad strategy in your other questions that you've done before too. Check to see if your answer worked. But we have to check it with square root. So the strategy for solving square root equations or radical equations, we need to get that square root all by itself. If it's all by itself and you square, it goes away. If it's not by itself and you square that whole side, you're going to have to FOIL and you might not get rid of it. So we have to first of all make sure that it's isolated, and then we want to square both sides. And in isolating it, it's okay if there's a number in front. Sometimes you'll leave the number in front. Sometimes you'll get rid of the number in front as well. It won't matter either way. So in question A, here's our term with the square root. It does have a number in front. So technically, it is already isolated. Sometimes I'm going to get rid of the number in front. What would you have to do to get rid of the number? Divide by 4. Okay? Sometimes I won't because, like, what happens if I take 3 to divide by 4? I get a fraction. And maybe I don't feel like having a fraction. So sometimes you might divide both sides if it makes your life easier. Sometimes if you think, oh, that might make my life a little bit more complicated, I might not. So in this question, let's say I leave it and I decide, okay, I've got my term with my square root by itself. I'm going to square this whole side. I'm going to square this whole side. Squaring 3 gives me 9. Squaring this is 4 root x times 4 root x. You see the 4 times 4 would give me 16. And the root x times root x will give me just x. And so we get x by itself to be, divide both sides by 16, 9/16. To verify, this is how we verify. We draw a line, we write left side on the left side, right side on the right side, and we take our original equation. The original equation, the left side was 3. On the original equation, the right side was 4, and then we replace the x with our answer to see if it works. And the square root of 16/9, that's the square root of 16 over the square root of 9. Oh, I wrote it in wrong, didn't I? Sorry. It's 9/16. The answer was 9/16. Square root of 9 is 3. The square root of 16 is 4. How do we multiply fractions? Multiply the tops, multiply the bottoms. Maybe you see that those 4s would just simplify to 1. And we get 3. These are identical, so that means that our final answer, we can put a check mark and circle it. It is the right answer. In B, here is our term with the square root. Is it all by itself? No. Do we have like terms? Yes. 13 and -7 are like terms, but they're on opposite sides of the equation, right? So what you do to one side, you do to the other. You see that you would add 7 to both sides, giving you 20 equals 2 root x plus 1. I have isolated the term with the square root. There is a number in front. In this situation, I would be like, ooh, but simplifying it would be pretty easy. Can you see you could divide both sides by 2? If I divide both sides by 2, I get smaller numbers. Smaller numbers are nice because once you're isolated, you're going to square both sides. So squaring 10 technically should be easier than squaring 20 for mental math. 10 times 10, that's 100. Squaring a square root sign will make your square root sign go away. And now, can we get x by itself? I sure hope so. We get x is equal to 99. Now we have to verify. Draw a straight line, left side and right side. Go back to the original equation, which on the left side had 13. On the right side had 2 times the square root of x plus 1 minus 7. Plug in 99. Square root of 100 is 10. 10 times 2 is 20. Minus 7 is 13. Check, check, check. So x equals 99 is the right answer. So try questions 4, 5, and 6 for a little bit right now.